Yes, it is recorded, yes. So the first thing that we're going to do is what? We're going to draw a free body diagram, right, on the spool. So the spool looks like that, right? So there you go. This is the spool. And we are going to put our forces. So we have, obviously, we are going to have this weight, mg. And we have essentially two rollers. So we are going to have RA. And then we have RB, right? And this is what we have on this, and then we also have a force applied on it, right? So the force is basically at a 30-degree. So the force is basically coming like that. Right? So that is your force T, and so these are the forces, right? And on the other diagram, basically, what are you going to put? What are you going to put on this diagram? You are going to put
moment.
A moment, exactly. So obviously alpha will always, ultimately alpha is going to follow the direction of the torque, right? The net torque applied on here. And now you see that RA and RB and MG will not create any torque on this object, right? Right, because they are all pointing toward kind of the center, right? So you can imagine that T will actually give you this IG alpha.
Doctor, I have a question concerning the alpha.
Yes.
It's the angular acceleration, right?
Yes.
So, but we always, in the cases we are looking at, alpha is always positive. So like the movement is always starting at omega equals 0 and increasing. That's why it's always in the direction of omega.
So omega, exactly. So here we're solving the problem at the beginning of the movement, right? Alpha, ultimately, you are going to get the direction of alpha from the torques. So it doesn't really matter actually if I put this arrow like this or to the top, right? Ultimately, the sign of alpha will actually follow the net of the torque. If you get alpha to be negative, it means that it is in the opposite direction of the torque that you assumed, right? Ultimately, let's say you got a value like, alpha is going to be minus, some whatever, something here, and then times the torque. Then alpha, the torque here is obviously, or times the tension force. So if alpha is minus, positive numbers multiplied by T, it means that alpha is going to be in the opposite direction than what you assumed, right? But here I'm assuming it like that because I know if I sum the torques about this point, right? And by the way, guys, it only suffices to sum the torques about one point to prove the direction of alpha. So here, if I use that point right here, right? And if I sum the torques about that point, I know that I will only end up with one torque caused by the tension, right? And I know these guys will not create any torque because they are all pointing toward the center, right? So the distance between this guy and the axis that I would use in this case would be 0, right? So again, guys, it only takes one point to prove the direction of alpha, right? Here, if you choose, strategically, if you choose G, alpha is going to be in that direction. Okay, so let us actually sum the torques.
Doctor?
Yes.
بس على سيرة الأوميجا نحن كل البروبلمز تبعنا we assume initially يعني omega equals 0.
No, we're going to solve a problem where omega is not 0, and then you guys will see how easy it is to actually.
بس إنه most of it, what ما يقولوا لنا we assume.
Exactly. Yes, exactly. If they tell you that you release a bar from rest, like let's say this pen is hinged like this and then I release it from rest, then yes, you're gonna take omega as 0 at the moment that you release it, right? But if I tell you to find the forces when the pen is already traveling with some angular velocity, then you would have to include that in the accelerations over here. And by the way, guys, am I missing any more accelerations over here? What is MAG in this case?
Zero.
0, exactly, right? Because this object is not moving, right? The spool is basically held over here, right? So obviously you also need to consider the geometry of the problem. Okay, very good. So if I actually sum the torques about point G in this case, and I'm considering my clockwise
قالوا شيء radius of gyration. شو يعني هيدا؟
Radius of gyration, exactly. So I've actually mentioned that already during one of the lectures. Can someone remind me what was the radius of gyration?
You gave an example of an axis and like a point rotating around that axis.
Yeah, so basically we know the moment of inertia for a disk is mr square, okay? Or I'm sorry, for a disk was mr square over 2. If sometimes you can have some, you know, very weird object, and then if they actually gave you the radius of gyration, simply you take m, right? mk square, where here k is the radius of gyration. Basically, you're assuming that this all object, for example, actually behaves like, you know, a ring, for example, right? That has a radius k, right? So that is the radius of gyration. So if I gave you the radius of gyration, it means I'm giving you the moment of inertia. The moment of inertia is
أنا
going to be
دايما
m.
I use IG equals to MK square.
Exactly. If I gave you that k is the radius of the gyration for that rigid body. In that case, it's a spool, right? So it has two radiuses. You know, it's a weird geometry if you were to calculate its moment of inertia. So they gave you k directly.
Okay.
Okay,
Thank
so
you.
k here is yes.
دكتور سؤال
Yes.
هون RA و RB are not equal من هيك ما في movement لأنه إذا بيكونوا equal بيطلع عند A.
Well, here, based on this problem, right? Well, we know this spool is going to be RA and RB basically are balancing the weight, right? And you know, RA is preventing this guy. You know, RB, for example, is preventing this guy from going to the right. RA is preventing this guy from going to the left. Okay, so here,
Yes, but they are
this is already
equal.
given to you as is in equilibrium. So we know this guy is not moving. Obviously, you might be able to create a very huge force to move that object. But here in the problem statement, I'll tell you that this object is simply rotating, right? It's a spool sitting on this platform, allowing this guy to only rotate. So we are only considering, you know, the torques that are creating rotation in order for us to calculate alpha.
Okay.
All right. So guys, you'll get the heck of it once we solve a couple more problems, and then you also guys solve the assignments. And my plan is actually we're going to do also another problem solving you know, session to kind of go over even more of these problems. But let us do this and then see how. So here you guys all agree, right, that MAG is 0, right? So this MAG here is 0. Why? Because this object is not moving, right? It's a spool sitting on this platform. Okay, so let us sum the torques about the G, right? And I'm gonna actually call this guy here R1, this small radius as R1, right? So if I sum the torques about the G, what am I going to get? I'll simply get T multiplied by R1, the rest of the guys are not doing any torque, right? And the net guy is gonna equal to how much? IG alpha, right? Where IG is equal to MK squared. And that is it. So you are getting the angular acceleration of the rigid body from the torques. So how do you solve alpha? Alpha is going to be equal to T R1 divided by IG, and that is equal to TR1 divided by IG, where IG is equal to MK squared. So now we have solved for alpha. The question is, how long will it take to basically unwrap 5 meters of that cable? Can someone tell me how can I solve this problem?
كيف الفورمولا تاع projectile بس مستعملون للروتيشن؟
I'm sorry?
يعني بنقول theta equals to alpha over 2t square وهذا.
Exactly. So now you have alpha. Alpha is constant, right? You guys agree? Alpha is constant on my head.
Yes.
Why?
Yes.
Because the tension is constant. The rest of the variables are constant. So if I apply this tension here, obviously in reality you are going to have friction on that, right? Here on these rollers, right? If we assume that, you know, we are in a perfect world where alpha is mainly, you know, here it's constant, then, you know, you're accelerating with a constant acceleration. Then how is omega? Omega is going to be always the integration of alpha dt, right? And, you know, it doesn't, right? So here we know omega is going to be t R1 MK squared multiplied by the time, right? Now, if I want to find theta, and by the way, omega here is going to be in radian per seconds, right? If I want to calculate theta of that rigid body, it's going to be the integration of this, right? And by the way, this is not the equations of the projectile, right? This is simply, you know, integrating an acceleration. So t squared over 2, right? And then now theta is going to be in radian. So what that really tells me that if I apply this tension, which was 300 Newton, with time I'm gonna basically unwind theta radian of that spool, right? But now how can I relate theta here to 5 meters of the cable? So the cable is being unwound at this radius, right? Not at that radius. how can I relate theta with displacement over here? Can someone tell me, like, how can I, let's say I have here ds. How can I relate that ds right here with change in the angle?
It's not ds equal r theta, the radius of the small.
Exactly, right? So ds is equal r d theta, or I can simply say that s is equal to r1 times theta, right? So theta is going to be equal to s over r1, right? So here s is going to be in meters, right? If r1 is in meters, so I can simply say, replace that here. So I'm going to say s over r1 is going to be equal to t r1 mk square t square over 2. So here I can, so I know s is going to be 5 meters. I know what my r1 is, and I can basically solve for the rest. So t square is going to be equal to 2s multiplied by mk square divided by t r1 square, and then I can basically take that t, and then this is going to be my solution. And then here basically you're going to replace s by 5 meters, t is 300, r1 is given to us from that as 0.8 in that case, and then we have the rest. So that is a solution, guys. You see, it's really basic and very straightforward solutions. Any questions, guys, on this?
And doctor, can we get the velocity of a point on the cable and then use 5 meters?
Yes,
By
exactly.
using kinematics.
Yeah, exactly. What is the velocity of, assuming this cable is not changing the angle? Can someone tell me what is the velocity of a point on the cable at any time?
We can relate it to 0.0. So the velocity is 0.
Yeah, we can relate to
cross
0.0, or
A.
we can simply use omega. So we know the velocity on the cable is simply
Omega r.
omega r1, right?
Yes.
Right, and then here we get the value. Obviously, if you want to represent that as a vector, you would need to put a frame, and then again, it's very straightforward. So this is the approach, guys. On the final exam, make sure you are drawing free body diagram. You are showing me the inertial accelerations, right? You are summing the moments to get alpha, and you are using alpha, for example, like in this case, to get omega, etc. So make sure you guys watch the lectures, right? The lectures are very important, especially on chapter 17. Make sure you really familiarize yourself with lectures 1, 2, and then 3. So what I would like to do is right now I want to actually solve a new problem.
بس دكتور سؤال سريع لأنه you brought up the final exam نحن كيف حيكون البروسيجر تبعه؟
The final exam will have some, maybe 10 true or false problems, but you will have about 4 problems actually that are similar to, kinematics problems or problems from this chapter. Okay, guys, I have a question for you guys. Let's say I actually have a pen like this. I have a bar sitting over here, okay? So the bar is sitting on a table that is horizontal, right? So G is actually a vector right now. You're not seeing G, okay? Very simple problem. Let's say now, actually, so I have this pen here. I basically am tying it with a force, and I'm applying a force in that direction. So I applied a force like that, right? And what I'll tell you is that the mass of this guy is M, and the length of it is L. All right. Now, can someone tell me what is the acceleration of the point A here as a result of F, M, and then L? So I have this guy like this. Simply, I'm pulling with a force, and then you see that there's going to be some rotation, right? How do you find, as soon as you apply the force, what is the acceleration of that point? So this guy is sitting on a table, gravity is acting downward, right? So there is no mg over here. How would you guys solve this problem?
بيصير عنا IG alpha.
Okay, so what do? We draw a free body diagram, right? So this is what we're gonna do. And obviously the table here is frictionless. There's no friction at all, right? So the free body diagram is actually already here, right? So this is a bar, and then this is a force. There's no mg over here because gravity is perpendicular to the plane of motion, right? So how do you think the acceleration diagram is gonna look like over here?
في horizontal acceleration.
Exactly. So I have mag, right? Always depend. So here, some people would say like the force is here, then you're gonna put mag here. No, ag is the acceleration of the center of gravity. So MAG actually has to be in the same direction as the force. So I have this guy as my MAG. How about what else? Am I going to have rotation?
Yes.
You will have rotation, exactly. Do I know its direction? No.
Yes.
Let's say I don't know its direction. Let's say I'm assuming it is like that, right? IG alpha. ما هيك؟ What is IG in this case?
ML
ML
squared.
squared over 12.
Exactly. IG is ml squared over 12. So this is your rotational inertia. Okay, so how do I get the acceleration of point A?
دكتور سؤال ليش ما عندي بالواي دايركشن A لأنه إذا بشده حينزل يعني إذا بتخيل عم بتشده حيكون عم يزيح.
I'll tell you why. Because F is equal to MAG as a vector, right? So this is the acceleration of the center of gravity. If the force is horizontal, AG has to be horizontal. Okay, if I have like a vertical component of the force, then yes, it will change here, right? But if that force is horizontal, AG has to follow the direction of the force. So AG has to be horizontal.
ماشي.
Okay. Okay, guys. So how do I get the acceleration of point A?
We got
نجيب
acceleration of point
الهوريزونتال.
AG.
Okay, so basically, I know AG.
We relate A to G.
Exactly. First of all, we're going to relate A to G. So I'm going to sum the forces in the horizontal going on the left. So I'm going to end up F is going to be equal to MAG, right? So I know AG is going to be equal F divided by M, right? So regardless of the mass of this or how long that is, the acceleration of the center of gravity will be horizontal, and it's going to be equal to the value of the force. Let's say I'm applying like 2 Newton or 3 Newton, whatever it is, divided by the mass of the bar, right? So AG will always be like that, independently of how big it is, whatever that angle here is, you know, that is independent. Okay, so we got that. How about, okay, what's next? How can I get the acceleration of point A?
We have to get
Sum of
alpha.
moments.
Exactly, we want to sum the moments. So we're going to sum the moments, and we can choose any point here, right? We can choose any point. We can sum this, we can choose that point, we can choose that point, or we can choose that point, right? And here, basically, where do you think we're going to sum the moments?
At F.
Exactly, we can sum, let's call that point O, and let's just put some angle here. Let's just call that theta, right? So what I would like to do is I'm going to sum the moments about point O, right? And I'm going to use, this is my direction, right? What do I get if I use that? So here I'm going to have 0, right? On this end, there are no moments applied in terms of the forces, right? So 0 is going to be equal to how much? So now I'm going to look at the moment arm of MAG, right? What is the moment arm of MAG?
L/2 sine theta.
Exactly. So I'm going to have MAG, right? Because it is in a counterclockwise direction. MAG multiplied by L/2 multiplied by sine theta, right? And then how about this guy?
Plus IG
IG alpha.
Plus IG alpha.
Plus IG alpha. Remember, now we have the acceleration of AG, right? It is F over M. Now we need to know alpha. So alpha is going to be equal to how much? Minus MAG L/2 sine theta divided by IG, right? What is AG? AG is equal to F over M, right? So alpha is going to be equal to minus. So if I put instead of AG F over M, basically M will cancel out. So I'm going to end up with F L/2 sine theta over IG. Is that the final answer for alpha, do you think, or that's it, right? So here we know the geometry of the system. We know theta, we know IG, we know L/2. We would need to know what? F, right? So if F is positive, it means that alpha is what?
The opposite direction.
Exactly, which
Clockwise.
makes sense.
Clockwise.
Which makes sense, right? So alpha is actually negative. Why? Because if in reality, if I actually have this pen and now actually I'm pulling on it in this direction, the initial angular acceleration of the pen will actually be opposite to what I've just assumed here, right? So there you go. So now you actually have alpha, right? And then ultimately IG, you just replace it by ml squared over 12, and you have alpha, and then you have AG. If I want to get the acceleration of point A, how do I get the acceleration of point A? So now I have alpha. This is the final answer of alpha, and then I have AG. So I'm going to say AP is going to be equal to AG plus alpha cross R P with respect to G minus omega square R P with respect to G. So now if I'm asking you to find the acceleration of point P as soon as the force is applied, meaning that omega squared is 0. But if I ask you after some time T, all you do is you just integrate alpha, that is it, right? Alpha dt from 0 to T. Why? Because alpha here is constant. Well, theta is going to change here, right? So that would be your problem, right? You won't be able to know that omega will actually be, if alpha is constant, then you can directly integrate alpha with respect to time. But if alpha actually is a function of theta, then you won't be able to do that. You would have to use like a numerical integration or use a computer, for example, to actually integrate that.
بس دكتور ما فينا نعمل omega equals alpha ما بتزبط؟
Yes, you can actually do alpha d theta is equal to omega d omega here, right? And then you actually, in this particular situation, yes, you will actually be able to integrate it that way. Okay, in this situation, yes, you will be able, because alpha is a function of theta, then you can replace alpha by its value, and then you can find the angular velocity of this as a result of that force, right, at any time, right? Remember, when the rotation is independent, so that point will actually change or whatever, but provided the force is always horizontal, then you can actually do that. Okay, so how do I continue from here? So from here, it is, now it is basically chapter 16, so I'm gonna rewrite that. So AG plus alpha cross RPG. So AP is going to be equal to AG basically was minus F over M I, right? And now I know my alpha, so I can keep alpha in that direction, but that is going to be minus alpha K, right? Because if alpha is in that direction, right, then it is alpha K, right? In that direction. So, obviously you don't want to forget about that frame. So the way that I have it right now is in the K direction, so I can just keep it as it is, right? So I can write this guy. If I want to put a vector on it, so all I have to do is do this, right? So just as a vector, that is going to be in the K direction. So plus minus F L over 2 sine theta IG K cross RP with respect to G is going to be what? So L over 2, right? Cosine theta I plus L over 2 sine theta J, right? Which is this guy, right? If that is my point A and then that is my point G, then this guy is going to be L over 2, and then obviously this guy is theta, so I have L over 2 cosine theta I plus L over 2 sine theta J. Okay, guys, any questions on this? This is a kind of problems that you should be expecting on the final exam, all right? So you have to be...
show us this whole equation آخر وحدة تبع AP.
This one here?
Yes, بس تشوفها.
Yeah. So I'm gonna kind of rewrite that. So now we do the cross product. So we have IJK. So I have minus F over AP minus F over M I. Now K cross I is going to be equal to J. So the first one going to be in the J direction, minus F L over 2 sine theta over IG. And then K cross I is J, so J. And then I have K cross J is minus I, but I have a minus, so it's going to be plus I. So plus FL over 2 sine theta IG. Right, and then I think here I forgot to multiply by L over 2 cosine theta, right? So L over 2 cosine theta here. And then here times L over 2 sine theta I. So just to rearrange that in the I direction, I'm going to have minus F over M plus F L over 2 sine theta square over IG plus J, you have minus FL over 2 square sine theta cosine theta, divide that by IG.
Doctor, concerning the final exam, we will have to, we can get partial grades, and you have to send our solutions by email. Or...
Yes, Yeah, I'm going to be looking at your final solutions on the final exam. So you
So
guys
we will
send me
send
your,
you.
yes, you will send me your handwritten solution. And there's one thing that actually the university is going to be implementing is after you solve your exam, we'll actually have another half an hour. So basically I can choose any student and then I can have an oral exam with him to ask him, more questions about how he solved his exam. So we also have that, so I'll be able to ask, any one of you guys to be able to explain how he solved his problem at the end of the exam. And then this is a new university criteria right now that they are having. Okay, but guys, do you guys understood how we're doing that, how this is being done? Right, it's pretty straightforward here, right? I mean, obviously there are some calculations, but the idea here is just doing the cross product and showing the solution, showing that.
Can you show us the figure when انت أخذت point P?
Yeah, sure. So point P here is at the top. Yeah, basically
okay.
point A that I used earlier, right? But I ultimately, yeah, so this is point P.
Okay, thank you.
Okay, so it is at the top. Any questions, guys, on this? Or
Doctor, you will be giving us IG.
I'm sorry?
هتعطينا انت ال IG بكل problem ولا نحن
Yes, so if it is a bar مثلا هيك, you know how to calculate the moment of inertia. If I gave you the radius of gyration, then you know what IG is going to be look like, right? If I gave you the moment of inertia about 0.0, do you know how to calculate about the center of gravity?
Parallel axis theorem.
You use the parallel axis theorem to convert the moment of inertia from this point to the center of gravity. But always on this diagram, you always have to use IG about the center of gravity. Okay, guys. So
parallel axis theorem يعني I always take the moment of inertia at the point I am plus mass times the distance.
Okay, so if you have a rigid body, right? So always you wanna, when you are drawing your inertial acceleration, right? You always wanna take the moment of inertia about the G, about the center of gravity times alpha, right? But let's say I don't give you a G. Let's say I gave you here. Let's call this guy point, P. Let's say I gave you IP. How do you calculate IG from IP? IG is gonna be equal to IP minus K plus M, the distance between RG with respect to P, right? The distance square, okay? So this is called parallel axis theorem. So if I gave you the moment of inertia about a point that is not the center of gravity, you can use this to relate it, to get the moment of inertia about the center of gravity.
Okay. Yeah.
All right. Okay, so what I'd like to do is let us actually solve one more problem. And then in this problem, basically, you have this like a pendulum. Let's say a pendulum is actually made out of two parts, right? So you have a linear bar that looks like that, and you actually have a disc over here. And then gravity is acting downward. And I'm gonna tell you that the radius of this guy is R, and the length from here to here is L. Okay? And the mass of this is M, and the mass of this guy is big M. Right? And let's say I also gave you the angle over here. I'm calling it theta. And let's say I actually gave you that this whole thing is actually rotating with an angular velocity omega. And you have omega here, right? And I'm actually going to keep it omega like that. And let's say you also actually have alpha like that, right? So at this angle, this whole system actually have an angular velocity omega, and it has an angular acceleration of alpha. All right. Now I'm going to ask you to find. I'm gonna do one more thing. There's actually a torque as well applied. Okay, you have a torque applied, rotational torque applied about that pin. I would like to find the reaction that actually develops on the pin. How do you think you can solve this problem? Right. So you have this pendulum. This guy is a disc. This guy is also a bar. L, and then as a result of omega and then alpha, I would like to find the reaction forces at that pin. How do I solve this problem? I'm gonna start by doing a free body diagram, right? How does the free body diagram look like on this guy?
The pin في
Wait.
horizontal or vertical, صح؟
Bravo, exactly. The pin you're gonna have horizontal, and you guys all know that, right? At the pin, obviously, you're gonna have horizontal, and then you also have the torque, right? The torque here is a known value, right? You have to know the torque would be provided to you, but AX and AY are unknown. Or actually, you can actually solve for the torque. Once we know alpha and then omega, we are actually able to solve it for the torque. But let us actually draw the free body diagram over here. How do you think the free body diagram is going to look like here? What else do I
Wait.
have? So
The
even
weight of
though
the bar and
exactly, so even though that rigid body is actually composed of two separate rigid bodies, so you know here this is actually a linear system, and then superposition applies. You can do the same forces here and then same forces here, and then you can do the forces here, right? So you don't actually have to find the center of gravity for this whole thing and then work on that. Obviously, you can replace that by like a bar with center of gravity here, right? Where you know what G is. But here we can just keep it like that and put mg where the center of gravity on each link, right? So I have mg here, and actually I have mg over here, right? And then this basically finishes up the forces that I have here. And how do you think I'm going to have on acceleration diagrams? So I have this guy is my, let's call this guy G1, and then this guy G2. Can someone tell me what are the inertial accelerations? I'm sorry? Yeah, so here we have omega, right? We have omega and then alpha. What do you think is going to be MAG, for example, on G1?
perpendicular to the bar.
Exactly, perpendicular to the bar. So I have alpha. So here on G1, basically, I'm going to have M, right? What is the acceleration here? But before I do that, actually, you guys need to log out and then log back in because time has ended here on this session because it's limited to 40 minutes. So I want to just stop, and then you guys can reconnect.